Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject physics and class 10, chapter number 12, electricity. Topics. The first topic is introduction. The second topic 12.1 electric current and circuit. Under this topic we are going to see the definition of electric current, switch, electric circuit, conventional current direction, 1 ampere, ammeter. The second topic 12.2 electric potential and potential difference. Under this topic we are going to see what is meant by electric potential difference, 1 volt and voltmeter. The first part is introduction. You know the meaning of the word electricity, and also it is one of the familiar word. You hear that because electricity is very important for human beings day-to-day life. Without electricity we can't run our life. So electricity has an important place in our modern society. It is a controllable and a convenient form of energy for a variety of uses in homes, schools, hospitals, industries, and so on. Why I say that the electricity is controllable? Because we can control the electricity by using switch. And also it is one form of the energy. You know that there are the different type of energies: thermal energy, wind energy, chemical energy, kinetic energy, potential energy. The same as electricity also one form of energy. It is used in homes, schools, hospitals, industries, and so on. So from this we can say that electricity is a very important in our life, important for our life. So what constitute electricity? Who constitute electricity? How does it flow in a electric circuit? We have such questions in our mind. And what are the factors that control or regulate the current through an electric circuit? Who control the current in the electric circuit? How we can control the electric current in the circuit? We have that questions in our mind. So in this chapter we are going to see the answer for such questions. In this chapter we shall attempt to answer such a questions. What are the questions? What constitute electricity? How does it flow in electric circuit? So what are the factors that control or regulate the current through an electric circuit? We are familiar with air current and water current. What is meant by air current and water current? We know that flowing water constitute water current in rivers. The hydrothermal energy, tidal energy. The tidal energy is nothing but using water we can produce the electricity. That is called tidal energy. So flowing water constitute water current in a river. So who constitute air current? The blowing wind constitute air current. So the blowing wind produced air current. Flowing water constitute water current. So who constitute electric current? Look at this image. This is a conductor. Here, if you take a conductor, the more number of atoms are present. So the atoms are represented. This is an atom, and this is also atom. This is also atom. Each atom consisting of protons and also electrons. The plus symbol represent protons and the negative symbol represent electrons. So here I connected the battery positive and negative. So when I connected the conductor to the battery, the electrons are moved from one atom to another atom. Look at this animation. Here the electrons are moved from one atom to another atom. So due to that electron movement, the electric current is constituted in the conductor. Similarly, if the electric source flows through a conductor, we say that there is an electric current in the conductor. Are you clear what is meant by air current, what is meant by water current and electric current? The electric source flows through the circuit or constitute electric current in the conductor. If you take a conductor, the conductor consisting of the many atoms, each atom consisting of protons and electrons. These electrons, when we connected this conductor to a battery, the electrons are moved from one atom to another atom. Due to the movement of the electrons, the electric current is constituted in the conductor. The next one, what is meant by a switch? In the introduction part, I said that the electricity is a controllable. So how we can control? Using switch, we can control the electricity. In a torch, we know that cells or battery, when placed in a proper order, provide flow of charges or an electric current through the torch bulb to glow. If you take a torch, you know that in a torch, the electric bulb is placed. How this electric bulb give light energy? And also you know that the torch light consisting of battery or cells. So this chemical energy of the battery give the energy to the bulb. Due to that, the light glow. We have also seen that torch gives the light only when its switch is on. And in this animation it was shown, when the switch is on, the torch gives light. When the switch is off, the torch does not give light. So what is the work of switch here? What does a switch do here? A switch makes a conducting link between the cell and bulb. So the working of the switch is, it is a conducting link between, this is a cell and this is a bulb. So it has a conducting link between the cell and also bulb. Are you understand what is meant by the switch? The switch is nothing but, the switch makes a conducting link between the cell and the bulb. What is meant by electric circuit? We know that what is meant by electric current and what is meant by the switch. Now we are going to see what is meant by electric circuit. Look at this image. Here I shown that on electric circuit. Here the blue color lines are the blue color are called electrons. It move from one place to another place, and this is the conductor. You know that the conductor consisting of the many atom, the atom consisting of electrons. When this conductor, the conductor is connected to the battery, the electrons are moved from one place to another place. So here I connected the bulb also. So a continuous and closed path of electric current is called an electric circuit. What is by continuous and closed path of electric current is called an electric circuit. Look at this circuit. This is a closed one. There is no gap in this here. And also here the electrons are move in a closed path also. So when the electrons are continuous and move in the closed path, that is called electric circuit. If the circuit is broken anywhere, the current stops flowing and the bulb does not glow. See here, when the switch is closed, the electrons are moved, the bulbs are glow. When the switch is open, the electrons movement are stop and the bulb is not glow. So when the electron will flow, when the path is continuous and closed path, then the electron will flow. Otherwise, the electron does not flow. So what is meant by electric circuit means you have to write the answer. A continuous and closed path of electric current is called an electric circuit. The next one, what is meant by atom? The atom is a tiny particle, is a present in everywhere. It consisting of protons, neutrons and electrons. The proton and the neutrons are present in the nucleus. The electrons are in the orbital, and also the electrons are moved in the orbital. It was clearly shown in this animation. See here, the electrons are moving in the orbitals. If you take a conductor, an electrical conductor is a substance in which electrical charge carriers, usually electrons, move easily from atom to atom with the application of voltage. So what is meant by conductor? Conductor is nothing but if you take a conductor, the conductor consisting of the many atoms. In these atoms, the electrons are easily moved from one atom to another atom when it is connected to a battery. But if you take an insulator, the insulator also contains atoms, but in these atoms, the electrons are not moved from one atom to another atom. So that type of conductors are called insulators. So the examples of conductor copper, steel, coal. If you take a copper, the number of electrons are, the electrical charge carriers are more. And also steel also conductor and gold also conductor. And what is meant by electric current? And what is meant by electric current? So electric current is expressed by the amount of charge flowing through a particular area in unit time. In other words, it is the rate of flow of electric charges. In circuit using metallic wires, electrons constitute the flow of charges. Look at this image. This is a conductor. You know that in the last slide I discussed that conductor. The conductor means the electrons are moved from one atom to another atom easily. And here the minus represent the electrons. The electrons are moved from one atom to another atom. So what is meant by electric current? The amount of charge flowing through a particular area in unit time. Here time is running, and this is one of unit area in the conductor. If you take a conductor, the conductor is this much of long, but I took only the one small unit area. So how much of electric charge flowing through a unit area in unit time, that is called electric current. So here time is running, the time is running, and I took the unit area. The electric charges are moving. So it constitutes the electric current. So I can write I equal to the electric current I equal to Q by T. The Q is nothing but electric charge. The electric charge is nothing but electrons. And T represent time. Are you clear what is meant by the electric current? Amount of charge flowing through a particular area in unit time. Instead of time, I can in the second, in other words, it is the rate of flow of electric charge. The rate represent for the time. So what is the direction of electric current? You know that who constitute the electric current? The electron constitute the electric current. So what is the direction of that electric current in the circuit? However, electrons were not known at the time when the phenomenon of electricity was first observed. So the scientists first they discovered electricity, but they don't know who produced the electricity in the atoms. So they don't know about the electrons. The scientists just observe that in the conductor produced the electricity. So electric current was considered to be the flow of positive charges, and the direction of flow of positive charge was taken to be the direction of electric current. And it is shown that the battery is connected positive and negative. So here the positive sign, the positive means the protons, negative means electrons. Before discovered the electron, the scientists are discovered the electricity. So they think that the positive charges are constitute electricity. So the direction of electric current is positive terminal to the negative terminal. But laterally only they know that the electrons only constitute the electricity. So conventionally in an electric circuit, the direction of electric current is taken as a opposite to the direction of flow of electrons, which are negative charges. So the normal current, the direction of electric current is opposite to the direction of flow of electrons. Maybe the electron or flow from A to B. The electrons are moved from A to B. So the current direction is B to A. It is a opposite to the flow of electrons. Maybe the current flow from B to A. So what is the electrons flow from B to A? What is the direction of electric current? The direction of electric current is A to B. That is opposite to the flow of electrons. So that current is called conventional current. So if you take electric current, If a net charge q flows across any cross section of a conductor in time t, then the current I through a cross section is. See here, if you take a conductor, this is a small area of cross section, and the electric charges are flowing through this unit area in unit time. So the current I is represented, I equal to, the current is represented by the letter I, and the electric charges, is represented by the letter Q, and T is the time. So the SI unit of electric charge is coulomb, and it is represented by the capital letter C, and the SI unit of time is second. Here the Q is the charge, the SI unit of this charge is coulomb, and T is the time, the SI unit of time is second, we know that. So the SI unit of electric current is here missed. One word is missed, that is coulomb per time, because I equal to Q by T. The Q is coulomb, T is second. So coulomb per second is the SI unit of electric current. Otherwise, we can say that the electric current is ampere. And what is meant by 1 coulomb? 1 coulomb, which is equivalent to the charge contained nearly 6 into 10 power 18 electrons. Here 18 was missed. So 6 into 10 power 18 electrons. We know that electron possesses a negative charge 1.6 into 10 power minus 19. Here minus 19 also missed. Sorry my dear students. Clearly I will explain once again. Here the SI unit of electric current is coulomb per second. Otherwise we can say that the SI unit of electric current is ampere. Now we are going to see what is meant by 1 coulomb. The 1 coulomb is nothing but it is equivalent to the charge contained 6 into 10 power 18 electrons. If you take 1 coulomb of charge means in this 1 coulomb of charge, how many electrons are present? 6 into 10 power 18 electrons are present. And we know that each electron possesses a charge 1.6 into 10 power minus 19. The minus 19 also missed. So the electric current is expressed by a unit ampere named after the French scientist Andre Marie Ampere. So 1 ampere is constituted by the flow of 1 coulomb of charge per 1 second. 1 coulomb per 1 second. So the 1 ampere is nothing but when 1 coulomb of charge is moving in 1 second, that is called 1 ampere. Are you clear what is maybe 1 ampere? Already we know that I equal to Q by T. The unit of I is ampere. So why I am saying that this is ampere? It is discovered by the French scientist Andre Marie Ampere. So the unit of current is ampere. So what is meant by 1 ampere? 1 ampere is nothing but when 1 coulomb of charge flow per 1 second, that is called 1 ampere. It is a very important one. What is meant by 1 ampere? And The small quantities of current are expressed in milliampere and microampere. The current are measured in two terms, one is a milliampere and a microampere. The milli means small letter m and ampere means A. 1 milliampere equal to 10 power minus 3. Sorry, the minus 3 is missed here. And 1 microampere is nothing but 10 power 10 power minus 6 ampere. The small quantity of current are measured in milliampere. The large quantity, the small quantity of current are measured by milliampere and microampere. The microampere means a 10 power minus 6. Comparing to the milliampere, the microampere are too small. So how can I measure the electric current in the circuit? Using ammeter, I can measure the electric current in the circuit. Look at this image. This is an ammeter. It has a two terminals. One is a positive terminal. This is a negative terminal and this is a positive terminal. And also see, this is ampere. Here maybe it may be, if you are measuring the small range of current means it is represented by the milliampere. Too small means it is represented by microampere. So here it is represented simple ampere and it has a reading 0 to 10 reading. Or you understand what is maybe the ammeter? The ammeter also one of the instrument used to measure the current in the circuit. It has two terminals, one is a negative and another one is a positive. The black always represent negative and the red always represent positive. So how I can connect this ammeter to the circuit to measure the electric current? An instrument called ammeter measures electric current in a circuit. Look at this image. This is a circuit. It consists of battery, bulb, ammeter and key. And see the direction of the current. The direction of the current is always positive to negative. That is a conventional direction current. The conventional direction current is a positive terminal to negative terminal. So the arrow mark is upward. And you have to mention the arrow mark in each line. For this wire, the current is upward, and here this is the direction of the current. For in this wire, the direction of current in this direction. For this wire, the direction of current is this. So where I connected the ammeter? I connected the ammeter to series of battery. It is always connected in series in a circuit through which a current is to be measured. I want to measure the current in this circuit means I have to connect the ammeter in the series. Maybe I can connect the ammeter here also. This is also series. Here also I will connect. Here also I can connect. So the ammeter must be connected in the series to the circuit. The figures shows the schematic diagram of a typical electric circuit comprising a cell, electric bulb, ammeter and a plug key. So this schematic diagram consisting of a battery, bulb, ammeter and plug key. Note that electric current flows in the circuit from the positive terminal of the cell to the negative terminal of the cell. Figure the bulb and ammeter. And see the current direction is a positive to negative. So the ammeter is nothing but it is used to measure the electric current in the circuit. And this word is a very important and serious. This ammeter must be always connected in a serious way. So I hope you understood what is meant by electric current and what is meant by electric circuit. When the electric current is flow in a continuous and closed path, that circuit is called electric circuit. And the definition of electric current, we know that I equal to q by t. The q by t is nothing but the number of flow of charge in a unit time, that is called electric current. And also you know the unit of q and unit of time and the unit of electric current, and you know the what is maybe 1 ampere and ammeter and their uses. Now you have to answer for such a questions. The first question, define electric current. The second question, write down the relationship between the electric current I passing in a conductor, charge q flowing in the conductor and time t. You have to write the relationship between the electric current, charge q and time, and write SI unit of electric current. There are the two unit of SI. There are two SI unit of electric current. You have to write it. Define 1 ampere electric current or SI unit of electric current. How is the direction of electric current related to the direction of flow of electric electrons in a wire? Name the instrument used to measure electric current in a circuit. How is ammeter connected in the circuit to measure electric current? Dear students, you have to watch the full video carefully and answer for such a questions. You are not able to answer for such a question, you have to watch again and again, because this is a very important lesson, so you don't confuse it in the starting itself. Thank you for watching.